So now we're going to be doing some volume problems with cylinders, cones, and spheres. And the first problem I thought of is an ice cream question. I have an ice cream scoop, which I measured the diameter to be 2 1/8 inches. And then on Amazon, I looked up ice cream cones, and there was only one type that had the dimensions for me. And it looked like the diameter of the cone was 1 11/16 inches, and the height was 3 5/16. And so here's the question, is if I put a scoop of ice cream on top of that cone and then just hold it, like I get talking and I just hold it, assuming that none of the cone, which we can see, will probably overhang because we can see that this diameter, now the diameter is going to be up here, so it's going to sit okay. It's not going to sit exactly halfway, but it'll sit in there. As long as it all melts inside, would the cone be enough to hold all of the melted ice cream? And so what do we need to do? Hopefully you said, find the volume of the sphere and the volume of the cone and see if the cone is bigger or equal to the sphere. And of course, if the sphere's volume is greater, then we know that even if it were to melt all inside the cone, eventually it would drip out. So let's make sure we write our volume formulas first. So for the sphere, and so I'm going to put V sub S to remind me which one I'm doing. Also, I'm going to write out the formula. 4/3 pi r cubed. So 4 times 3.14 times, the radius should be half of 2 1/8, which is going to be 1 1/16 cubed. And then I will divide all of that by 3. And of course, I'm going to rely on my calculator to do that. So I get 5.02175. I don't know how many decimals I'm going to need, so I'll keep a few of these. 175. After that's a 1, so I'm just going to round it to that one. And this is cubic inches. Now, if you got the 15 whatever, don't forget to divide by 3. It's so easy to forget to divide by 3. All right, now for the cone. So volume of the cone is going to be 1/3 of capital B H. Capital B is the circle, so pi r squared times the height. So in practice, I will be doing 3.14 times half of 1 11/16. Let's see that. So half of 1 is 0.5. Half of 11/16 is 11/32. We can take half of it by doubling the bottom. So if I add that to 16/32, which is half, we should get 27/32. Or you can just turn that to a decimal if you want to. And then my height is 3 5/16. But I know how to use the fraction button on my calculator, so I'm going to type it in like that. And then I need to remember to divide that by 3. So I get the volume of the cone can hold 2.46826, so maybe I'll round it to 3 right here, cubic inches. So about half. It can only hold about half of that sphere of ice cream. Now, if you got 7.4 something, remember you got to divide by 3. All right, let's do another fun one. Let's say that there's this pencil bag that looks something like this. And then it has like a dome on the top. Don't know if you can tell what that looks like. It's supposed to. I don't know, it's just not getting any prettier. Well, it came off in my mind better than it did on a sketch. It's supposed to be basically half of a cylinder with like this little dome on top. What I want you to do is get thinking about what are these shapes made up of. And I've already said that this is half of a cylinder. But this one, now if this were a full cylinder and this is on top, well then it would be a hemisphere, right? A half of a sphere. But this, since it's been cut in half, this should be what kind of sphere? like a fourth of a sphere. One half of a cylinder. So if it's like a pencil bag, let's make it 8 inches by 3 inches. So let's find the volume. Well, the volume of a cylinder is simply the area of the base shape, which is pi times radius squared, times the height. Now, sometimes people go ahead and find that area first and say, oh, I'll take half of it later. I will forget. So I'm just going to go ahead right now and in my formula, make that divided by 2. So I'm going to put C for cylinder this time. So 3.14 times 1.5 squared times the height, which is 8. And then I'll divide all that by 2. Now remember, this is a parenthesis. I almost looked at that and went, why does that look like an 18? Well, it's my handwriting. So I did divide by 2, right? Yep, 28.26. And that will be cubic inches. And to that, I'm going to add 1/4 of the sphere. So the volume of the sphere is 4/3 pi r cubed. And since we only need 1/4 of it, times 1/4. Or maybe I should have put that times 1/4 on the front, because I can see that I can simplify that and make my life a little bit easier. See, 1/4 of 4/3 is 1/3. You basically see this cross canceling right there. So 1/3. So on the top, 1 times 3.14 times the radius, 1.5 cubed, divided by 3. And I got 3.5325 cubic inches. And I want to add that. So 31.7925. I'm just going to go ahead and round it. Since I'm going to round it, I'll put wavy equal signs. $31.8 cubic inches total. So I added these two together to get 31.8 cubic inches.